Yeah, so a very, very warm welcome to you, Atulya. A session which has been getting postponed for quite a few sessions now. I think the last we met was with the Excel, right?
Yes, ma'am.
Yeah. And have you finished your HR analytics also, or you're halfway through?
It's still going on. It's I'm in the data science and business analytics.
So one
All
session
right.
is pending.
Okay. 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 No, I'm asking you with respect to understanding if there is anything else of databases that you have touch based with. So before I start, Atulya, if you could just let me know how much of databases do you understand as of now? I know we did Excel.
Hmm.
Have you worked on any database before? Has there been any interaction on that? Or have you ever used SQL before?
Using SQL, I haven't used it any yet, but I have heard it about from a lot of friends in community.
Your voice is very low,
Any
Atulya. Is your mic,
one second.
or is that to me?
वो नहीं आ रही थी एकदम क्लियर, थोड़ी कम आ रही थी.
Hmm.
नहीं ठीक है, I think it's fine. Keep going.
Now it sounds okay. Yeah.
Am I
Go
audible
ahead.
now?
Yeah, yeah.
Is it okay?
Yes, much better. Thank you.
Regarding SQL, I haven't
Hmm.
used it much in my technical life. And
All right.
regarding database, what I'm not clear what is the context of using database.
Okay. Okay, so let me do this. I'll start with databases first. So the way we'll go about is we are here to learn about SQL basically, but to learn SQL, we will have to get some groundwork done in terms of what are databases, what is an RDBMS. So I'll take you through these terms which we will require. And then most likely at the end of today's session, we should be able to install SQL, the tool that we want to use, which will be MySQL is what we'll be using as a database management system. We should be able to install it in your system so that from next session onwards, we will be getting into only the SQL part. Is that okay? Wherever you find me that my pace is slow or fast, you can let me know. We can go through it a little faster or slow. Is that okay, Rahul? You want me to add or change anything?
No, I think it's fine.
It's fine now. Good.
Okay. So like I said, to get into SQL, we will be trying to understand what are databases first. So I would prefer if we make it more interactive, otherwise it can get very boring. This is more about the theory part of understanding databases. So Atulya, what are your thoughts on what is a database? Before that, what is data, if I may ask you? What would you mean by the word data in any context for that matter? I'm sure you have used the term, right?
Yes, I have. Data, I mean, just like if we are like browsing Amazon for certain products, we generate sort of data regarding what are the preferences are, what kind of products we want to buy, like groceries, mobile phones, and something like that. The preferences most of the customers look into. Uh, Preferences have when the festival season is there. What is a desirable products customer want to buy in the festival seasons? That kind of
So you're
data.
saying the preferences piece or the choice that a customer makes, that is what you would call data?
In a sort of,
that...
yes, yeah.
Okay, so let me just clarify. Data is anything which is a fact by any means, okay, which has been collected for some particular reason, that becomes data. Your name being Atulya itself is data, okay, or my name being Parul is data. Now, if we are having a training at 3 p.m., we have a lot of data points in this. Training itself is a data, the time becomes another data point. All right. So data can be any fact by that logic. So can you think now of any other example to tell me what is data? It can be anything. It can be a name, it can be a number, it can be time, because you have different types of data.
Driving license, Aadhaar card, one of the kind of data.
Yes, they can be data.
Mm-hmm.
Right? Names of students, names of employees are data. Name of a company is a data point.
Mm-hmm.
An email is also a data point. And like you were saying, choices made by a customer on an Amazon or something, that choice or preference, if it is stored, that again becomes another data point. So and if you remember in Excel, we had discussed, right? You used to have types of data when you store. You had date, time. In analytics, if you have ever studied, then there are other data types like character, number, and so on.
Numerical.
So they then become the types of data. But basically, any fact which has been collected for a reference or analysis perspective, that becomes data. All right. Now let's understand now what is a database. So anything that you can tell me now that you understand data? What is a database?
Storehouse of data, storage house of data.
In a way, yes. So a database is basically an organized collection of data. Okay. Which is stored in any electronic format, be it an Excel sheet, or ideally, if you're writing names on a notebook also, they are a physical form of data stored. Right? So that can also become a database. If you have a long list of people and you have some other data points along with it, it becomes a database. What does a database allow you to do? It allows you to input, manage, organize, and retrieve data quickly. Okay. And normally a database, traditionally it used to have records, which were the rows, and the fields, which were the columns. And these were stored in database files. Now, before I come to database table, let's understand how was it done earlier. So it is not that Excel was always there, right? You had only data files floating all over. Excel, in fact, got a little more organized. So let me take you to the next. Just give me a minute. Yes, so you used to have these database systems, which were more like files which are lying in your system, different files. In fact, even as Excel files, if you have multiple files where you have records of people written with you, it used to get difficult for people to manage, especially when the quantum was big. It's more like when there are 10 students, I can write it on a notebook. When they become 100, I prefer to go to an electronic medium. And when that 100 become lakhs of users, or for example, the case that you were saying in Amazon or a Grofers, where there are tons of users, it becomes very difficult to manage that with simple file systems, with simple files which you could store in electronic media. Now, what used to happen was when you stored these data points in files, and if you had to do any kind of query with them, or you had to fetch an information out of that, it used to get difficult. The reasons for that was there used to be data redundancy. Would you understand data redundancy? Which is there would be data duplication in a way.
Mm-hmm.
There would be data
Copy.
inconsistency.
Mm-hmm.
There could be different formats of files, there could be duplication, and then each time if you have to cull out some information from that, from the different set of files, you needed to write a specific customized program to do it, because these were multiple files. Okay, to do this, actually let me give you an example. Wait, let me just put it in an Excel. So you can see my Excel file, right? What we'll do here is, we'll put, for example, I'm creating a small data set with employee ID, employee name, employee address. Okay. And for example, I have now, if this is my, for example, employee records file that I have created, okay, and I have another data set where I have the data of, for example, their leave management. Okay, and here what I have is employee ID, leave quantity, for example. Okay. Now, what you would essentially want in these two data sets is, if I have created here, say 5 employee IDs for an example, and if I put here an employee ID which is like E001, who has taken, say, leaves number as 4. Now, will you be able to link these two data files? So you have a data file which has this data where your employee ID is from 1 to 5 with details of employees, and a leave management file which you have. Here you have other records also. Now, will you be able to link all the records here with this file? Or will there be a problem?
In a way, you can, yes. You can. Like employee
Okay.
1 takes 4 leaves, and employee 2 takes 5.
No, but this has become E001 now.
Mm-hmm.
And there is no E corresponding E001 here.
Mm-hmm.
Right? So you
Of
will
course.
not be able to link it because they are not the same.
Mm-hmm.
Correct? And in Excel, we had learned that, yeah, you can put validations, but then it will be a complex thing to do in Excel for you. You could have multiple other data files here, like for promotions or things like that. So what happens in this case is, This is what I'm calling that there will be an inconsistency, because you will not be able to validate your data. Also, it's possible that by mistake somebody again adds a 5 year. That is what I mean by redundancy happening, right? So there is this kind of a possibility if we use files and not databases. We'll come to what all will databases do for it, but this is one of the bigger problems that we have. Let's go back to the page. Yeah, so that is about data redundancy and inconsistency that you can see. And why is this happening? Because your files are actually in isolation. They are not talking to each other. That's the problem that you have, right? It can also lead to integrity problems. Integrity problems were where I said that E001 doesn't exist in the other file. Also, to add any constraint or make any change, it becomes difficult because you have to either do manually or create customized code for it. Or if it is an Excel file, of course, you can do a lot of validations and things like that. But you will have to be on the guard constantly because it has to apply to all the cells also. You might at times not, you might put a validation, but you might not really have it for the full column or things like that. Those errors can create bigger issues for you. Right? Also, atomicity of data. By atomicity of data, I mean whenever, so for example, if it is a banking database that you have, that you've collected, and it's similar in Excel files for you, what you would want that if one account is getting debited, the other account gets credited, right? If there is a transaction happening. So say there is a transaction happening and there is a debit from account A and a credit to account B. Okay. In an Excel or in any of the data files that you use, this kind of a transaction, you will not be able to control end to end, which we'll be able to do in a database. In a database, what we will be able to do is, if the transaction fails at any point, we do a complete rollover of the transaction. Are you able to get this, Atulya?
Yes, yes.
So what I'm saying, if there is a transaction from account A to account B, where there is a debit happening in account A and a credit happening in account B, and if we are supposed to record all these things in our data file, if we have to do it in an Excel, there would be ideally two data files that you would have. So one where you will do the debit and in the other where you will record the credit piece. But it will be very difficult for you to control that both are successfully done and only then the records get input. So things like that are much more easy when we use the databases. The other issue which also happens is concurrent access by multiple users. However, in today's world, this has got a little easier with Google Sheets and things like that. But still, concurrent transactions in files is a challenge. And the other bigger problem which we have is security problems, because in files, you can have one password, you cannot have multiple users with different passwords, with different kind of rights and things like that. Right? So this is what we were discussing, that this is all about the database, data files when they were used. So earlier, database systems were more, and this is more a history for us. I wouldn't get into the detail of this, but just to give you a snapshot of what it is. Earlier, the data processing was done using magnetic tapes. And then there used to be these punch cards. I'm sure you have not seen them. When I had started my career, it was Unix systems, and we knew that earlier generation used to use punch cards, but we have not seen them either. But we used to have floppy drives where you had database stored for us, which kind of got redundant slowly. Now, gradually by the 1980s somewhere is where object-oriented database systems came into play. And then in the 90s, it was about web commerce. And 2000, I think that is what your generation would be, Atulya, where it is about XML, where it is about all the NoSQL databases, the big data, Hadoop and all that. Because you have all these web-based applications. and your data started getting stored now on cloud. So from a magnetic drive, it has moved to where it is now, where it is being stored essentially on clouds, etc. Right? So it is a very distributed data that you have today, which is stored in different clouds, and there can be access given to a lot of different users. Let me go back to, yes, so that was about data files, and data files are no more really used. What is basically used is databases because of the various issues that we saw in data files. Now, how it will get overcome in databases is what we'll discuss here. So database is basically a collection of different tables, and each table has rows and columns. This is basically the most simplest form of data storage. Now, databases today also store documents, they store images, they store all kinds of content. It's not just simple data points that we store, and we will come to that gradually. Some of the databases which you can come across very commonly is like you have an employee database in organizations, you have student database in colleges, you have patient database in hospitals, and so on. Okay, so this is essentially how you can depict a database. It basically has a lot of tables inside, and each table, if it is blown up, this is how the rows and columns are. All right. Now let's come to what is a relational database. So a relational database is also like any database. It has tables, it's a collection of tables. But here there are relationships between each of the tables. So there's a concept of a primary key which is used to identify each row. So I'm sure in like the database we just now saw, where we had say 3 columns of employee ID, employee name, and employee address, right? Now for each record to be identified uniquely, you put in a unique key, which is what is called a primary key. So would you be able to tell me the Excel which I showed you, what would be the primary key in that? Atulya, any thoughts? We just put up an Excel, right, with 3 columns. What do you think should be the primary key in that? Let me show you that Excel. Yes, I'm asking you, what should be the primary key in this, you think? Primary key is basically a field or a column which is used to uniquely identify a row.
You're on mute.
Employee ID.
Employee ID, absolutely, yeah.
Mhm.
So employee ID can here become a primary key. And what should we do with this?
It is same employee ID, employee
No,
number.
but here employee 2 can again take leave, no?
Mhm.
I can probably have dates of leave also here. Right? So how should I have a primary key here? Just give me a minute to just switch on my charger, which I missed. Atulya, you can think what if there's anything we can put for primary key in this. So some tables don't have primary key also.
Acha.
Not every table will have a primary key. Okay.
Maybe a unique request number or
Yeah, we
form.
can put a unique request number or something of that sort to locate the data point, but it can be an idle table also without a primary key.
Got it.
So in any RDBMS, there are two important things which you should know. One is an entity and one is an attribute. Now, what is an entity? Entity can be any object. So in the case that we were discussing in Excel, what do you think is an entity?
ID, title, price. In this,
Employee is an entity there.
no.
Okay. And the attributes are where we are describing the employee. So the employee address is description of employee, employee ID is description of employee. All that becomes attributes.
Attributes.
Okay.
Sorry, I missed the point of RDBMS. You saying?
I'll come back to it, Rahul.
Okay. Okay.
I'll come back to it.
Okay.
So what we are discussing, what we have done until now is we have understood what is data. We have understood what is a database, how is it holding the data, which is in form of tables. And we have understood what is an entity and what are the attributes. Right? Now, next we are talking about is a database management system. So first you have data, on that you have database, which is basically a collection of these data points. And then on top of it is what you have a database management system. Now, database management system is basically a software application which is used to manage, as the word says, right? It is used to perform different kind of tasks on the objects which are there in the database. For example, if it is having employee and attributes of employee, if there's information you want to pull out, you will be able to do it using a DBMS. DBMS basically is a collection of applications. So it's like pre-written code that you have, which is used to access the data. All right. And this is done in such a way that it allows you to create your own reports or pull out any information from various data files also. Data files here, I would mean various tables in case of a database. So this application is basically, it will allow you to edit your data in any format, which could be you can create, delete, update, all those kind of things you will be able to do using this predefined code. And that is what is a database management system. Like here, this application is responsible for handling data requests, committing changes to the data. Committing changes means updating the data in any format. Enforcing the structure of the database, including that the database is stored properly, there are no rules violated. So like in Excel, you had a problem that in employee ID, you suddenly see a new E001, right? In a database, that will not be allowed by the database itself. Why is it that it's not allowed? Because actually there is a pre-written inbuilt code in it. That's how the system is made. So it's like an application which has a pre-written code which is taking care of all these things. So it basically maintains all kind of relationships that are there between the databases, the various tables that you have. It is also good because it allows you to take backup, recovery, all of that, which in case of data files is difficult. And it ensures that all your data is stored in the right validation that you have defined for a database. All right. So this is precisely what I was saying. So before this database is where you have your data points, which you store in the database in form of tables, etc. For this database, to be processing anything on it, you need a DBMS, which is a database management system. There are various types of DBMS, and we'll come to that. And from the DBMS for any application or reporting purpose is where SQL comes in. I hope this is clear because this is like the architecture of what we are studying and why we are studying. So for you to understand SQL, it becomes very important that you understand what is database, what is DBMS, and under it, what are the different types of RDMS. And then for SQL also, you use different kind of tools, right? Like you have IDEs, you have these development environments for doing any kind of coding. Similarly, for SQL code also, you have environments where you can write your code or write your queries, right? And then from SQL, of course, you use different SQL codes, which can then cater to various applications, whether they are web applications or SAP application or various application systems that any system has. Yeah. Okay, now let me take you to what is RDBMS. So RDBMS is basically a system where you have defined relationships between your tables. And they are not just freely lying tables. So a database would be any collection of tables is what you can call as a database. But once you define relationships between various tables, it becomes a RDBMS, and that is what is called a relational database management system. This is one of the most popular ones because it kind of gives you a complete understanding of what you have. Because just having files will not help you, or just having tables lying in your database will not help you. Any querying becomes difficult. So the relational database management system is a more robust system from that aspect. Under RDBMS, you have different types of RDBMS. So I'm sure Microsoft Access, have you used ever? Rahul, I think you would have used. We used to use a lot in our earlier days.
Yeah.
So Microsoft Access is one type of RDBMS, which is with the Microsoft Office platform, of course. It's a paid one. And you have a very popular Microsoft SQL server, which is used in enterprises. Oracle, which is used in enterprises for very big data. But these are again paid. MySQL is another RDBMS, which is a open source or a freeware that we have available with us. And this is the tool that this is the RDBMS that we'll be using for going forward. Okay. Now under RDBMS, the advantages that you have are, one is it allows you to predefine your rules. In the sense, like just now we saw a case, right, where we put employee ID as 1 and later we tried to put as E001. So when you create a table under an RDBMS system, it will allow you to define in the table what is the kind of column you should have. Or in the column, what are the data types that you should allow. So for example, if the same data that I showed you in Excel, if I had it in a database and I had defined it as a numeric number, I would not be able to enter a record with E001. Are you with me on this, Atulya?
Yes, yes. For example, date of a particular system.
Yes, yes. So what I'm trying to say is, if this was a table, and if I had said this is a number format, I would not be allowed to put in E001 here. This input itself would have got rejected, right? But because it's Excel, there has been no issue here. The other advantages of RDBMS are like DBMS, which is your disaster recovery, your backups. You can do scheduling of backups through a DBMS. So very commonly in most organizations where you use MS SQL Server or Oracle, there is a scheduler for your own database backup, which is something similar to, you see your WhatsApp backup happening every day, kind of, no? Something similar to that. So those facilities are also there, which you would not get in your data files. But RDBMS basically will be maintaining relationship between all your data entities. So this is a little bit about SQL Server. SQL Server is a very highly scalable. It is like Oracle. Oracle is also very highly scalable. MySQL is not as robust a system as SQL Server or Oracle Server. Now the objects which are there in RDBMS. So any RDBMS contains similar stuff, which is one is the database itself. It contains the transaction logs. So would you understand what is a transaction log? It's like, for example, if you're trying to insert a new record,
Just
say a new record with
like an entry.
yeah, like an entry. If that entry has gone through or not, it will keep a log of that also. So in its software, it will keep record that you tried to insert this at this particular time. If it was successful, it will keep a record of that. If it was not successful, it will keep a record of that. It will also keep a record of the error that it has thrown. So it records all the transactions log. Okay. Then it has tables. It has indexes. Indexes, do you understand?
In this one question, Parul,
Yeah.
in the transaction log, it also you have to define what's the start point of a transaction, or it also, say for example, I'm trying to access my website, but page has not opened because of, say, memory overload on my web server, on my website server. So will that be considered as a transaction log because it never reached? So basically, it's like a shop where you're saying any customer who has come in, we have a transaction, whether he has bought, not bought, how much time he stayed in the shop, things like that.
Yes.
But
yes.
if a customer could not even enter because there were too many people already in the shop, or for any other reason, will that also be considered as a transaction log, or will that not?
It will be. Let me explain to you how. So when you have a web application, like you're saying, so if, one second. So when you have a web application, and if your web application is here, ideally you would have a, below the web application, you would have the website code, which will internally be connected. So you will have a connecting software, which is more like a mediator that you have, and then you would have the database, right? Now you're saying somebody came to this website code. When they came to the website code, now it depends. Did this code itself throw the error, or was the database memory or full or something of that sort?
The database memory.
If the database memory was full, yes, it will record the transaction. There is, of course, a setting in the DBMS where you can decide that what all do you want to record. It allows you to do that, most database management systems. But if it is hitting the database and there has been a memory full error or overflow, stack overflow or something of that sort, it will record that as a transaction log. Yeah, so then you have tables, indexes. Indexes are nothing but an internal system which it creates where it kind of sorts the data for its own self. So if your data is indexed, and normally today's RDBMS do it automatically, you don't even have to ask for. Earlier days, we had to do indexing on databases. But if they are indexed, it will work faster for you because they're internally sorted in a way. They're sorted normally on the primary key that you have declared. So if it is like employee ID, it will be sorted on the employee ID. The advantage it has is when it is indexed data, the retrieval is much faster. Retrieval time is reduced significantly. That's the same thing like in Excel also. If it is sorted data, you can manually see where it is much faster, right? It's the same thing which is in a system fashion. Then you have file groups, not so important, views, stored procedures, users and roles. Views are basically for each user, you might want a different view. So this, when we'll go to SQL, I'll show you how are used. Stored procedures are like automatically scheduled things which you can write and keep as code in the database management system. For an example, if you are a website where what you want to do is you don't want an online insertion of records for any new customer who's giving you a feedback, because feedback is not really very important record, right? You would want it once in a while. It's not an online transaction record that you want. So what you can do is you can schedule it. You can write a stored procedure in a fashion that after every 3 hours, the feedback gets updated in all your database files. That's what is stored procedures. We used to, in my earlier days, I remember we used to write stored procedures for a backup scheduled at say night 2 o'clock. So you write a stored procedure and you keep it. Automatically it runs through them. Yeah? And DBMS also allows you with a lot of users and roles. So you can define different users with different roles.
So stored procedure can also be a report?
No. Stored procedure is in, it can generate a report.
Okay, it can RDBM. Okay, fine. It can generate, but okay.
Yeah. So a stored procedure.
You still need SQL to query it out.
No, a stored procedure is inside SQL only.
Oh,
so suppose you want a report of the sales that happen every day at 9 o'clock, for example, you can write a query which will be inside a stored procedure, which can also be scheduled, and it will throw up this data every day at 9 o'clock for you.
Yeah, so that's what I'm saying. Even a scheduled report can be part of stored procedures.
Yes. Most scheduled reports are part of stored.
Like our decrement reports.
Yes. Yes, those are all stored procedures written. Now these depend, the only difference is MySQL will be a little different, Oracle will be different, and SQL Server will be different. But basically they'll use stored procedure. Okay, now let's just understand what is the difference in DBMS and RDBMS. So a DBMS, like I said, is basically the most important difference here is there is no relation between tables in a DBMS. So it also does not impose any kind of constraint. Or you can say there is not much of security with regard to data manipulation. Atulya, are you able to understand this piece? Security with regard to data manipulation, what do I mean?
There's like no certain type of encryption or something like that, asset protection.
No, 1 second. Let me just show it to you with my Excel. Now here, if tomorrow if you see these two data tables that we had created sort of, if tomorrow I remove this record 2 or this person resigns, just give me a minute. Yeah, so if this person resigns tomorrow, which is your employee ID 2, there will be no automated way which will remove these records here. Right? But
because
they are not linked by any fashion. They are not related to each other by any way. Right? But in an RDBMS, you will be able to do this. So it keeps your data more intact, more secure, or whenever you do data manipulation, this is called data manipulation. Whenever you try to update a record or something, that's called data manipulation. So whenever you do any kind of data manipulation, it takes care because it is related database.
Okay.
Yeah, so RDBMS forms the basis for structured query language, which is what is SQL. This is just a table for you to see the difference between a DBMS and RDBMS. So DBMS stores data as a file. Here it is stored in the form of tables, right? It allows only single users. RDBMS allows multiple users. There is a concept of ACID, which is basically atomicity, consistency, isolation, and durability. So in a regular database, like I showed you, right, it can develop inconsistencies if you have different files. So in an RDBMS, they obey this ACID law. That's what it is called in the software world. It's basically, it takes care of atomicity, which is it treats, like I told you, a transaction, right? I gave you an example of a transaction where if there is a debit from A to a credit to B, then it takes care of the end-to-end transaction piece. That is atomicity. It maintains consistency, isolation, and durability. Now, of course, for RDBMS, because these applications are much more robust, they need a lot of, their hardware and software needs are also much higher. Because
what is meant by isolation, like separate from groups, or what is the context of isolation here?
1 second, let me explain to you. Give me a minute. I think I'll look in an Excel and explain. So isolation is like if there are transactions happening concurrently. Like if 5 users are working together on the application and they are all doing banking transactions. So each transaction, like I said, if it is a A-B transaction, it would take care of doing it end to end, but each transaction will be treated in isolation. Are you able to get this? So it's more about concurrency that you can understand. So it's not that one transaction can interfere with another transaction.
There should be no type of collision like.
Yeah, there'll be no type of collision between the two. There'll be no collision between the two. So the main goal of this isolation is basically concurrency control. So out of say 5 transactions, if one has failed, it will not impact the other 4. The other 4 will go ahead on their own, and if the other 4 transactions are completed end to end, that update will happen. Okay.
Say for example, I'm just giving an example.
Yeah.
Suppose I'm doing a banking transaction, which is bulk banking transaction. Suppose I'm paying to 400 vendors at one go. Out of which, because of some error, bank transaction of say 4 vendors did not go through. Either the account was wrong, bank server did not respond, anything can happen. So rest of the 396 transactions will still go through, although they are part of the same file. So I'm uploading one batch, batch file of 400 transactions built into that, out of which in that batch, so it will not fail the entire batch, it will let go the batch with 396 transactions going through for throwing an error as a response back.
Absolutely. So your 396 transactions will live in isolation and get completed in isolation. The 4 with error will not go through. Right? Is that clear, Atulya?
Yes.
Okay, now DBMS also does not support distributed databases. So in RDBMS, what also happens is if you create 2 different databases, they can be connected and you can have a relationship and they can be talking to each other, which does not happen in DBMS. Okay. Some examples of DBMS would be a Windows registry. I'm not sure if you're aware of that. XML files you should be aware of. So data stored in XML files is very common. Windows registry is basically your Windows system which has a registry database, which is about every software having a unique number if you have ever seen. That's what's a Windows registry. But however, what is more widely used is the RDBMS, and we'll be focusing on this. Okay. Now, under database, there are different data models to say, which is, just give me a minute. Yeah, so under data models, we have, of course, the data collection, which is, you have different tools which are used for data, data relationships, data semantics, data constraints, and all of that. And very important element of this is entity relationship model, which is also what we'll cover today. You have relational models and you have, so under the relational database, you have different kinds also, which can be object-oriented model, semi-structured model, network model, hierarchical model. We'll not be getting into all of that. What we'll be focusing on is the entity relationship model. Now, whenever you have a database, there are basically three different views of that. So one is the view which is what the user wants to see, and this is more like your reports, right? Then there is a conceptual schema, and schema is nothing but it's more like a blueprint of your database, which is how you think your tables are and how they are related, right? And then there is a physical schema. Physical schema is actually what your files and indexes are. What they use, that is what is called physical schema. So schema is more a logical structure of your database. And once you define a schema for your database, which is your blueprint, which is more like how will your tables look like? What will be the structure of your tables? What will be the fields? What will be the type of data types? All of that comes under schema defining. Okay. So whenever we create a database, we define the schema of a database also. All right. And you also have something called as an instance of a database. Instance is more like the actual content of the database. So this, when I go to SQL, I'll tell you where it is. You'll be able to get more clarity on this. And this is on the type of database users that we were discussing earlier, right? What are the different kinds of users? So you could have users who are wanting it only from an application programming point of view. Or you could have users who are, they want to write something which can invoke permanent application programs. So basis the type of user you have, you give him the rights in your database. All right. Then you also have a database administrator for every DBMS. This you would have heard more often. And this is the person who actually defines your schema, defines how it will be stored, what will be the different users, what are the different access rights you will give to which user. This is the person who will define what are the integrity constraints that you want. He will be monitoring the performance. So all your issues of stack overflow or memory full, all that comes with the database administrator. He basically coordinates all the activities with respect to the database. Okay. Yeah, so that basically ends your thing about database and RDBMS, which we have discussed. Now what we'll be moving to is what are these ER diagrams or entity relationship diagrams, and why we are going to do this. Let's understand this first before we get into it. So what happens in a database is, and as a case study which we'll do at the end of this class today, whenever you have to create any database, you first need to understand what are your different entities that you have. And entities are like your objects, right? Like employees is one entity, manager is one entity, and so on. For each of these entities, you will have different attributes around the entity. You will also try and connect these to each of the other entity. So that is what is called an entity relationship diagram. We'll try to create a relationship between all the different entities. And that is how you will be relating your tables in the database. All right. This diagram, once you have made it, this kind of forms your schema for the database. This is how your database looks. Once your schema is ready, well, I might have to switch off my video. It's showing internet unstable. So excuse me for some time. Yeah, so the schema, once you have defined your ER diagram, then you're able to form your schema. Once you define your schema, after which is when you can input data into the database. Right? Are the steps broadly clear to you of how we go about? Atulya, any doubts on this?
I'm clear a little bit, but I think when we will practice, that will make much clearer.
Okay, okay, okay. So let me just, or is it okay if we take a small break of 5-10 minutes and come back and then we start with ER diagrams?
Okay, sure.
Yeah.
Is that okay?
Yeah.
So we'll take a 10-minute break. Let's be back by 4:10. It's 4 o'clock. A minute to 4 o'clock. Yeah. Okay. Yes, Atulya. Clear so far? Any doubt you have in what we have discussed until now? Any query?
Not yet, but I think we'll go further. I'll have some doubts.
Okay. Okay.
Mhm.
I'm asking you because in the last 10 minutes, if there's a new query which has come up, maybe you could just ask that.
Yeah, many times it is easier to relate once, you start looking at it.
Yes, that's true. Okay, so what we'll move to is your diagram. So what we are looking at it, what we're going to look at it is entity relationship diagrams. These form a very, very important part of any database. Now, let's understand this. So yeah, well, maybe we could start with this. So for example, if you are in a university, okay, before you start creating a table to store data, you need to somewhere start thinking of what will be where, kind of. You need to understand what are the different data points, how will you organize them, because like we said, database is an organized structure of data, right? So you need to actually practically start thinking as to where will you put what. And the starting point for that is what are the different entities in the data that you're trying to collect. Now it becomes very, very important to have a sort of blueprint with you. It's something like if you want to construct a house, you always tend to make a plan, right? You tend to get an AutoCAD drawing also ideally, so that you know exactly where, what dimension, which wall will be in which direction, all of that piece. The reason you do it is not that without a diagram you will not be able to construct the house. The reason you do it is you want it in an organized fashion and you would prefer it to be the way you want it. Similarly, in a database also, because you want your database to be doing certain amount of activities, keeping that in mind, you would have different entities which will be part of your database. It's very important that you define a sort of a blueprint for what you want. So in most organizations, there is always a ER diagram which is there as part of their RDBMS system. So for every new database that is created, there is a diagram that is created, which is nothing but it's basically a blueprint of what you want. Okay. So what it does is it basically relates. Sorry, something that I did.
1 second, just pause for a minute.
Yeah. Rahul sir, any inputs from you? You want me to go faster or something? You're on mute. I can't hear you. You said something.
No, I said all good.
Okay. You are with your laptop here, sir? Okay.
Oh.
Okay.
Mhm.
Yeah, so ER diagram will basically define all the terms related to entity relationship modeling, which will be about what is the entity, what are the instance, what are the attributes, what is the relationship, cardinality, and primary key we'll discuss in detail going forward. It will draw up the relationships like we said, and it will help us recognize the attributes and cardinalities. Let me just do this 1 second. Let me put it on screen. Yes. So like I said, a database model is where we'll be using this ER diagram, which is the blueprint. This ER diagram will basically allow us to sketch the database design. It's more like a drawing that you're going to create. And in the RDBMS, like if we use a MySQL or a MS SQL server or Oracle for that matter, for every database, it allows you to create this graphical interface which shows you how your data looks like, how your database looks like. It's widely used in database designing, and it exists in a system and the relation. This doesn't. Okay, now why are we doing this? Basically for a better understanding of the database. And when we do the case, you will realize that it helps you clear in your mind also how your different entities are or what are the different attributes. Otherwise, it's more on paper than on in your thought actually. Okay. It is basically used to communicate the logical structure of the database. And the other handy part about this, can you think of any other purpose of doing this ERD other than what is mentioned here? From a usability perspective, I'm asking you. So you're basically creating a diagram where you say, this is my employee table and this is how my leave database is, this is how my promotion data table will look like and so on. And you will build relationships. I'm asking you, do you think of any other use which could be for this of this ERD? Why would you make it? Any thoughts? Can't hear you. Are you saying something, Rahul?
No, I'm not.
Okay. Yeah, Tulya, I'm asking you any other reasons you can think why we should do an ERD? Or if you can reiterate for me, what have you understood of ERD? The reason I'm asking you is because it's important that you know what are the purpose of doing it.
I understand it is a kind of representation of data.
It is a representation of your database.
Mm.
And it is like a blueprint. So like I gave you an example, like for a house, if you have a blueprint. Now imagine when you want to renovate your house, normally you go back to your blueprint, right? Even though it's physical. Yeah, in terms of knowledge transfer, it really helps. So ERD is also very useful for knowledge transfer. Basically, if your data administrator quits his job and there's another person who comes in place, or if you want to modify or add something in your database, it's important that you know what are the existing relationships of which entity. That's where your ERD plays a big role. So one, of course, is for anybody who's new to the database can go through the ERD, they will understand. From a maintenance perspective, also it helps because if, for example, there is a memory issue or an overflow happening, this diagram will help you understand where is what. So mentally, you can treat it like an AutoCAD drawing of your own house, the drawing that the architect has, right? So the components of an ERD are basically entity, which are the different objects that you have, the relationships, cardinality, and attributes. Let me take you to each of them. Now the relationships are two types. One is you can have an optional relationship, you need to have a mandatory relationship. An optional relationship can be, for example, an employee may or may not be assigned to a department. A patient may or may not be assigned to a bed. That is a kind of an optional relationship, right? And a mandatory relationship is, for example, if you're having an a student database, then you will have every student attached to one course at least, right? That becomes a mandatory relationship. Or every course will be taught at least by one teacher. That is a mandatory relationship. Okay. Then you have cardinality constraints, which is the number of entities to which another entity can be associated, or the number of instances one entity can have with another entity. So the minimum cardinality is 0, which is you can have a 0 relationship to another entity, and the maximum can be any number that you can think of, depends on the case. So in cardinality, you can have a one-to-one relationship, which is, for example, you can have one head of department, one manager as head of department, right? And each department can also have only one head, right? If you have HOD position and you have departments as another column, it can be only 1:1 relationship. But if it is employees and department, it can be 1:many relationship, because one employee can work in one department can have multiple employees. You also have many to many relationship, which here the example given is the teacher teaches many students. And a student is also taught by many teachers. Can you think of one more example of all these three? One-to-one relationship, can you give me another example, Atulya, if you can think of? It can be any database system. It can be student, it can be patient database, it can be university database, whichever you can think of. An example of where two entities are related with a 1:1 relationship.
Prime Minister of a country, one to one.
Yes, absolutely.
Mhm.
So every country can have only one prime minister.
Mhm.
Right? And every prime minister can also associate with only one country. So it is a 1:1 relationship. One to many, can you think of another example?
Soldier working in a particular regiment or troop.
Sorry?
A soldier in a particular
Soldier
troop
working
or
in different regiments.
regiment or troop. Mhm.
Is that what you said? Yes, possible.
Mhm.
Possible. Good example. And
Mhm.
many to many, any example?
Mhm. No, I'm not getting any ideas on many to many.
It can be like Rahul, would you want to add?
Yeah, I think there can be many cases. For example, shoppers and e-com sites they visit. So
Yes,
shoppers
yes. Very good
can
example.
go to various e-com sites, and even e-com sites can have many
Shoppers as well.
shoppers. Then group of people and the sports they play. People can play various sports, and one
Yes.
sports can have various people.
Yes.
Many to
Employees
many
and
relation.
projects, it's like that. Employees can be assigned to different projects, and projects can have
Yeah.
multiple employees.
Yeah. So employees and their competencies, for example, or their
Yes.
skills. One
Yes.
employee can have 5 skills, and one skill set can have many employees in that various group of
Absolutely,
people.
absolutely. Okay. Now this is how cardinality constraints are depicted in the diagrams. So this you will not have to draw in most of the RDBMS system. This will be like inbuilt. You will have to pick and drop. It's more like in your PowerPoint you use the drawings, right? So when it is a one relationship, this is how you put 2 lines. When it's mandatory many, these are the 3 lines that come. Okay. This is for optional one, a 0 and a 1. And this is for optional many. So many sign remains like this, which is here optional many. And for optional, a 0 comes in. All right. And when this many becomes 1, it becomes 2 ones like this. For every entity, you will be using a box like this. This is also inbuilt in the system, but you should know about it. Okay. So here's another example of cardinality constraint. In our model, we wish to indicate that each school may enroll many students or may not enroll any students at all. So this example, what they're asking us to do is, how do you depict this in cardinality? So I just showed you the symbols that are used, right? We also wish to indicate that each student exactly attends one school. So this is how your cardinality will look like. So when you see it in an RDBMS, this is the structure that will come up on its own. You will have to draw it, of course, with drag and drop, but this is how it is. So each student attends at least one school. So this is for that one school. This is the relationship. These are the two. What is student and school here? These are the two entities. These are the two entities that we have. Right? And each school at least enrolls at least 0 and at the most many students.
Many students.
So if you can see wherever, like in this one, this relationship is about at least 0 and many students. So this whole symbol piece comes near the student, the entity student, right? When it is about each student, at least one or at most one school, because the second entity school has this relationship of at most one or at least one, the symbol comes near the school. All right. Now, how do you create an ERD? So the first thing you need to do is you need
Can I just stay
to
there for a minute?
identify.
Can I just go back there? Sorry.
Yeah.
Yeah. So school can enroll 0 students. So each student should choose at least one school.
Yes.
And at most one. So mandatorily one school for each student.
Yes.
And for school, it can be optional many. Okay,
many or 0.
So when it's a optional many, it also includes 0, right?
Yes.
Because it is optional many.
Yes.
This symbol. Okay.
So here it can allow a 0 or it can allow many. This O is for 0. So if we see here, this is optional 1 and the last one was optional many.
So optional many includes 0.
Yes.
Okay. Got it.
Optional many includes 0. At the least 0 and most many. That's what it is.
So there is any symbol for a positive value, which means at least one. That's mandatorily
Which
many.
is this one?
So mandatorily many. No, that is mandatorily one.
Yes.
The mandatorily many means you cannot have one. You can need to have more than one. So there is no option called as more than 0.
More than 0 will either be mandatory one or mandatory many, no?
No. So I'm saying, for example, I want a symbol for. So a school cannot have 0 student. They should have at least one student for school to be operational.
Right.
But if I put mandatorily, so if I put optional many,
then you will use
if I say optional many, then school can have 0 also.
So you will use mandatory many.
Mandatory many. Okay, got it. So mandatory many can also have one.
Mandatory many can have one.
Okay, then it clarifies. Yeah.
But it is not mandatory one.
Yeah, got it. Mandatory many. Yeah.
So when we used to study this, I remember we used to have this symbol for many. This was our symbol for one. This is how we used to define relationships.
1 to infinity, yeah.
1 to many, right?
Got it.
Okay, now to create an ER diagram, the things that you will need is first, of course, you need to identify the entities, because that is how you will draw those boxes, right? That is how you will know whether it is student, school, how many entities you have. Once you identify the entities, you also need to identify the attributes of the entities. So that I'll show you, which will be more like, for a student, what will be the attributes? Attributes is basically things describing that entity. So it can be student ID, it can be student name, yeah, roll numbers, student address, all of that will become attributes. For a school, it can be school address, school code if there is any, type of school, and so on. Then you need to identify the primary keys. Primary keys are basically the unique identifiers for that particular table or entity that you're looking at. And we need to identify the relationship between these entities. After you identify the relationships, you also need to get into the cardinality constraint, which is what we discuss now. That what is the kind of relationship? Is it one to one? Is it one to many? And then you draw the ERD. All right. So this is again the steps. Yes, these are broadly the steps which have been defined at a more molecular level so that we follow it well. So we will do this exercise where we will try and create a ER diagram. Okay. So like we said, the first step will be to identify the entities. So this is an exercise where we are where there is a company which has several departments. Each department has a supervisor and at least one employee. Employees must be assigned to at least one, but possibly more departments. At least one employee is assigned to a project, but an employee may be on vacation and not assigned to any projects. So the important data fields are the names of departments, projects, supervisors, and employees, as well as the supervisor and employee number and a unique project number. So do you want to kind of list down the possible entities that you can think of before I move to the next slide?
Yeah, so this is exercise, right?
Yes.
Yeah, just a second.
So what I want you to do is note down the entities that you can see in this exercise, so that we'll create the ER diagram.
Okay.
Atulya, done? You
Done.
want me to wait or done?
Done.
Okay, so what are the entities that you have listed, Atulya?
Like departments, employee, project, particular project, unique project number, employee number, he, she is on vacation or not.
Okay, let me do this. Let me take you to how do you find the entities, and you would have done the same thing. So what you do is you basically go through the statement that's written and you identify them from it. So right. So here, for example, a company can be an entity, has several departments. Departments can be an entity. Each department has a supervisor. Supervisor can be an entity, and at least one employee. Right? Employees must be assigned to at least one, but possibly more departments. At least one employee is assigned to a project. So project is another entity. But an employee may be on vacation and not assigned to any projects. The important data fields are the names of departments. Okay. So here your entities will be company, departments, supervisor, employee, and project. And then we are saying a true entity should have more than one instance. What would I mean by that here? And by that logic, should company be an entity?
What's the question?
I'm saying a true entity should have more than one instance. So basically, when you try to identify your entities from here, from the statements that are already given to you, if you find that there is more than one instant of that object, you can be assured that that is a true entity that you have identified. For example, in this case, if you see project has more instances, right? You have another project here.
Yeah.
Department has more instances. Okay. So here probably company, because it has only a single instance, you can leave it as an entity, though it is an entity. But from this perspective of creating this database, it might not be relevant. So it will not be called a true entity, right? The others, which are department, supervisor, employee, project, will become your true entities. Now the next step will be for us to find the relationships between these entities. So how do you find relationships? So one is, of course, if you see the statement is too complex, you can get confused as to what is the relationship. And this is a more simpler database statement that you have. You can have even more complex because there are a lot more entities. This is just a simpler example that I've taken. So the technique to do this is you basically create a matrix for yourself. where you put all the entities on the rows and columns. Okay, the same entities that you have identified. Then for each entity, you write the relationship. For example, so once you have created the matrix, what you do is you go through each cell and decide whether or not there is an association. For example, department, there won't be an association. Now, employee and department, what will be the relationship? An employee belongs to a department, right? Between supervisor and department, supervisor runs the department, correct? Then between project and department, you don't find a relationship in the content that is available with you. So similar exercise you will do with the second column then. So for example, department and employee. So department is assigned to employee. Project uses employee and so on. Okay. Once you have done this, you have basically found which entities are related. So then whatever relationships you have found out, you actually just put them in words. And then we'll go to the cardinality piece. So basically, like we identified earlier, a department is assigned to an employee. A department is run by a supervisor, right? This is the relationship between department employee, department supervisor. Similarly, an employee belongs to a department. An employee works on a project, correct? A supervisor runs a department. A project uses an employee. Now remember, this is not directly mentioned here. Here it says employees must be assigned to at least one. And that's how you use that there is a assigned relationship between department and employee. Correct? Employee is assigned to a project. So you'll have to cull out this relationship information from this data. What I'm only showing you is, because it can be complex, a simpler way to do it is create a 2x2 matrix, go through the statements again, put the relationships, whatever you understand. And where you see a no relationship, leave it a blank. Okay. Once you have done this, all your identified relationships in one place, then we'll get into creating the diagram. So all your entities will be placed in rectangles, which in our case are what? There's no student we have, right? We have department, employees, projects, right? All those will be rectangles. The diamond shapes are, and the lines are used to represent the relationships. So I'll show you further. So for example, employees work on projects. So the same statements, I've now created a diagram out of it. Department is run by supervisor. Okay. Department is assigned to employee. Then whatever you have tabulated as relationships, you put them all together on one diagram with the entities. So now you have your departments run by supervisor, department is assigned to employee, employee works on project, right? Now let's come to cardinality. So now you will have to check.
Just go back. Just go back in the previous slide. Can there be a scenario that the whole department working on a particular project?
Can be. If that relationship is mentioned.
Mm-hmm.
For example, a particular department is working on one project.
Mm-hmm.
If that is mentioned in the data that you have, in the content that you have, yes, that can be. Okay. Now you'll have to define the cardinality. Cardinality means whatever relationships that you have defined here, you'll have to see how many are 1:1, how many are 1:many. That process you'll have to do, right? So we are saying, for example, here, each department has one supervisor. In the department, each supervisor will have one department. Each employee can belong to one or more departments. Now, this information, one or more departments, was actually mentioned in the write-up. Employees must be assigned to at least one, but possibly more departments. That's how it becomes 1:many. So you normally, when you want to create a database, you don't make your own assumptions because you wouldn't know of the system that is followed in that particular organization, like in this case. Some companies can have a case where they say each employee can be assigned only to one department. Right? Now, this company seems to be saying that employees must be assigned at least one, but possibly more departments. So it is allowing one and many relationship. At least one employee is assigned to a project. So every project has at least one employee. But from an employee perspective, he may be on vacation and not assigned to a project. So that becomes like a 1:0. Right?
Right.
So that is what is here. Each department must have one or more employees. Each project must have one or more employees. From a project perspective, each employee can have 0 or more projects. This is what we discussed in the end. So if employee is on vacation, he can be on 0 projects. Right? So these were your cardinalities that we discussed, one and only one, one or more, 0 or more, 0 or 1. Then you'll go ahead and, so this is what I shared earlier also, right? One and only one, how it is depicted.
Same.
This is the same thing, yes. Only for you to understand when it is on this side, this means that each instance of A is related to minimum one and maximum many instances of B.
Mm-hmm.
So where you're defining the relationship closer to which entity, that's how the relation is. Okay? If the same thing was here, the meaning would have been the reverse. So it's not just about putting these signs, it's also about where you put them. So for example, this one is each instance of B is related to a minimum 1 and a maximum of 1 instance of A. So can you give me an example of the employee thing which we did where it can be this second type of relationship? Or any instance you can think of, which is only minimum 1 and a maximum of 1 instance. Or in what we are discussing, is there one which is only one relation?
Yeah, there is.
Yeah. Atulya, can you point it out? Where there's only one.
Sorry?
I'm asking, is there any instance where each instance of B is related to a minimum of 1 and a maximum of 1, which means it's a 1:1 relation?
A person can have only one other card.
Sorry?
Person can have only one Aadhaar card identity proof.
Person can have only one identity proof.
Identity proof, yeah.
Yeah, sure. So each person can have only one, but one identity proof, or you're saying one Aadhaar card number?
Aadhaar card, yeah. Just take an example of an Aadhaar card.
Yeah. So each person can have only one Aadhaar card. That becomes a 1:1 relationship. Here, each department has one supervisor is also 1:1. Because each supervisor can also have only one department. So this is a 1:1 relationship. So this is how your ER diagram would look like. Would you want to attempt it on your own, creating this? Which means I will leave you here, and can you create the diagram? Is that doable? I'm sure you have put up the entities on your notebook or something that you have with you, right?
Yes.
Right? These are all the relationships that are there.
Yeah, let's try out.
I think give it a try. These are the symbols if you need. I can leave it at this symbol so that it helps you recollect. If you want me to change the screen, let me know. Just give it a rough try, Atulya. It will just help me know that you have understood what we have discussed so far. वो cheating कर रहा है क्या अतुल्य? He's looking up as if there's some cheat sheet.
नहीं, फैन आवाज हो रही.
Okay.
It said that one employee can be assigned to many departments also, right? That's what it said, the question?
Yes, yes. Each employee can belong to one or more departments.
Yeah. And you can also have these symbols on either side of the line.
In the sense?
So you can. So just go to the symbols. So suppose this is a symbol. Let's say the first one.
Yes.
And let's say there is a box on the other side as well. Okay.
It can be then either side.
So the can be on either side. It
But
can be on both the sides.
No, then you will draw another line.
Another line. Okay, got it. Got it. Okay. Fine.
One relationship will have only one symbol set.
Understood. Because in this, department and employee has two-sided relationship.
Yes.
For supervisor and departments also. Right.
The supervisor and department is one-sided.
Each supervisor has one department. Each department has one
supervisor. So they are 1:1. That is 1:1. No, that is locked. That is locked.
So what you can do for now is, like Rahul, you're asking, yes, when you define
this was both, I was asking. Yeah, this was I was
when
asking.
You have both ways relationships, you will have to put this here and here. You're saying.
Yes.
In
yes.
that case, you're actually saying there are two relationships.
That's right.
If there are two relationships, you will have two lines. And your diagram is far more complex.
Yes, yes.
Correct. This is what I was referring to, because there are relationship is different on both the ends.
Yes. So, for example, here we are saying department and supervisor, like you're saying 1:1. This is just a simple depiction where we are saying run by, right? But if you see in the ER diagram, there will be actually two lines.
Yeah, so Atulya is right, because two lines are necessary, the way I see it, because it can also happen. What is given is each department is run by a supervisor.
Right.
Okay. And every supervisor can manage only one department.
Right.
Because
And
there is
that's why
also
you need these
possibilities
two.
there could be a supervisor who can manage many departments. So relationship on both the ends may change. So every
Yes.
department
Yes.
needs a supervisor, but one supervisor can manage multiple departments as well. So like what has happened in the lower part of it, where employees and projects.
Absolutely.
Where
Here it can be zero or many.
correct. Any employee can have even a zero project, but project cannot have zero employees.
Yes. Yes.
So project cannot have zero employees, which means it will go on the other end. Okay, got it. But employee can have zero or many projects. Understood. Clear. I think this makes sense.
Okay. Atulya, clear?
Just 1 minute.
Sure, sure, sure. Once this piece is clear, then the whole relationship between tables that we form gets very easy. And once this piece is strong for us, actually querying becomes easy. So the whole objective for me to ensure you understand this is that you understand the querying much easily.
Okay, done. Yeah.
Okay. Just give me a minute. Just give me a minute. My system is kind of hung with Excel. I'll just stop it and start again. Let's do this. Can I just quickly ask you all to make a few more small ER relationships? More from a practice perspective, but quicker ones.
Yeah.
Okay. So Can we make a relationship between customer and order? So one entity is customer, one entity is order. You're just putting two rectangular blocks. I want you to put the relationship that will happen between the two. Let me know if you're not able to hear me. It's showing me as unstable internet on my laptop.
Your voice is clear.
Okay. Atulya, done? You done, Atulya?
Yes, ma'am.
Yeah. So customer to orders, we said, right? So what is the relationship?
It will have both side relationship, and it can have zero and more than one, both side.
From customer to order, it can be zero orders or many.
Yeah, zero orders or many.
And from order to
For
customer?
orders, like yes, for zero to many. For a particular product, it can be a zero customers.
No, if there is an order, it has to have at least one customer, no?
It is not a product yet. At least one, yes.
At least one or many? Which one?
Uh, least, at least one with many.
Many will be there.
Yes, many will be there.
So each order can have many customers.
Yes.
No, each order can have only one customer. One order can have only one customer. No?
One order can have one. Okay, yes. I took it out of the context. हाँ मैंने order की जगह product के बारे में सोचते चल रहा था. Sorry. One order will only have one customer.
So you're right. One customer can have 0 orders or can have many orders.
Many orders, but one order.
One order can have
one
only
customer.
one customer.
One customer.
Right?
Mandatory one.
Mandatory one, yes.
Because order cannot have.
One. It is one and only one.
Yeah, one and only. And good point, Atulya, is also extending it to products.
Yeah, if it is product, then what happens?
Yeah, so now move from order to product. Atulya, move from order to product.
Then it will be from what was the other term?
Customer and product. Now you have two entities.
No. Mandatory one, and other term was
optional.
Optional to many. Both sides. Like customer can have 0 orders, 0 products in their cart, and can have many, and vice versa.
Don't confuse cart with order.
Then you're mixing up two things.
Yeah. Order is order. Order means order placed.
Customer can have 0. Right now we'll take as a product first. So 0 products and can have many products, and for a particular product there can be many customers or can be 0.
Yeah. Now put order in customer to order to products, because order is a combination of products, as you rightly said.
Right.
Now what is the relationship between order and product?
Order and product. Particular product can have 0 orders or many.
Yes.
And the other way?
Can have at least one.
Very good. Yeah.
Absolutely.
Every order need to have at least one product and can have many products. Yeah. Very good.
Good. So I think this is fairly clear. Just share. Yeah. So this is what we discussed, customer and order. Here there are two more examples. So one is about employees' insurance claims for dependents. So now you will be able to read it, right, Atulya? Easy, right? Yes. So employee can claim for 0 or many dependents. Every dependent will have to be claimed at least by one employee.
One employee.
Right? Similarly, instructor can teach 0 or many classes. Each class needs to be taught by at least one instructor.
Right.
Now this is a similar ERD for course enrollment. More like a pro-touch enrollment process. So a student can either enroll in 0 or many courses. Each course should have at least one or many students. Right? And then each course is taught by one instructor. This can be many also in some cases. If you have multiple instructors teaching the same course. And each instructor can teach 0 or multiple courses.
Perfect.
Clear?
Yeah.
I'll just hold it for a minute. You can see through. If you need any confusion, you can ask me. because I think now you're able to understand on your own, right? So I'll just pause here for a minute. We'll go through it and I'll move. Done, Atulya?
Yes, ma'am.
Or can you explain this one? Can you explain all the relationships which are here?
An
So that we
advisor
are
can
on
have,
the same page. Yeah.
sorry.
So that we are on same page. Go ahead.
An advisor can have 0 students under him, or have many, and vice
Yes.
versa. Like and students can have only one mandatory one advisor for him.
Right.
The rest is same.
Okay.
Only one question here, Parul.
Yeah.
Here, if you're saying student is an entity, which means we are talking about an enrolled student here, or even a prospect is a student considered here.
Even a prospect here.
Okay, understood. Then it's fair.
So these, of course, will depend on the situation of the database.
I agree. So if it is an enrolled student, then जो course के बाजू वाला option है वो हट जाएगा.
वो
It
हट
will be
जाएगा.
वो हट जाएगा. Got it.
Fair. Now this is with primary keys. So you can also highlight the primary key of each entity that you have. For example, here department ka primary key taken is department name. It can also be department ID. Supervisor's primary key is supervisor number. And this depiction that I'm showing you here in different systems, in different RDBMS, the depiction can be a little different, but predominantly this symbol of rectangle will be used for entities. This will be used for processes. Okay. 1:many, it can be this, or it can be 1:infinity sign, which I showed you. Those are the two kinds of symbols used. Now let's move to attributes. So in attributes, what we do is you basically try to find out what are the things which are described.
Shall we take a quick break?
Yeah, we can. We can take a 10-minute break. Let's be back by 1 second. 5:14, so 5:24.
Okay.
10 minutes? Yeah. So we can proceed further. Yes, so the next step is about identifying the attributes. In this step, what we do is we try and identify and name all the attributes essential to the system without matching it to a particular entity. So like we did the exercise of identifying entities, you can also identify attributes. First, you will find out all the things which are describing, list it down, and then put it up against whichever entity they belong to. Okay. The best way to do this is to study the forms, files, reports currently kept by the user of the system, and you circle out, like I showed you in the entity piece which we did, where we read and highlight stuff, right? And then there will be some attributes which you cannot transfer. So imagine this is about creating a database from, say, you have a file of employee records and you're trying to create a database out of that. Now there could be fields like maybe a signature which cannot be shifted. You cannot create a soft copy of that immediately. Though with a scanner and OCR, etc., you can do it, but you will not be immediately able to put it in a database. So you can identify things which you can transfer and which you can not transfer. The things which you can transfer is what you will add as attributes to your entities. And whenever you make a database, you should keep in mind that you use the latest available data, because at times the physical records could be older. Even if it is a soft copy, there are different versions of data points that people store in the system. And we all don't have a tendency of naming our files very aptly with date, etc. So it's always important that you pick up the latest data. So the only attributes indicated are the names of departments, project supervisors, employees, as well as supervisor and employee number and a unique project number. Then you map the attributes. For mapping the attributes, you will need to know with which entity they are to be mapped. For example, department number, you should know that it is with department entity, obviously. Right? Employee ID will be with employee. If you have attributes left over without corresponding entities, you may have missed an entity. So sometimes if it is a big database, it makes sense to do this exercise, because at times you might realize at the end that you have missed a particular entity, which could be as small as, for example, we were collecting data on leaves, right? So maybe there is a leave type entity, an entity of leave which you should have, which would have leave ID and leave type, which you would have missed. But while collecting attributes, you realize that that is something you need to do. So this happens quite often when you do it. If you make databases, you end up in situations where you later realize that you should have had this entity, or you later add up a new entity, right? So this is how you map your attributes. So for example, department name, and then you find out the entity to each. And once you have done this exercise broadly, this is how your ER diagram would look like. Now this is a simpler one. When we do it in databases, it is quite complex at times. And this ER diagram, you should ideally do a recheck for any cardinality issues that you can have. Now, why are these important? Why are we defining this one is too many, many is too many? Why do you think Where do you think it could be useful at a later stage? And that's the reason we spend so much time on this. Any thoughts?
So that like there should not be any kind of collision between them. Uh,
Okay.
uh,
Kind of. Yes.
Like in a case of bank transaction, there should be a link between them from one data point to data point to have a clarity which is dependent and which is independent of one another.
Okay. Okay. So it basically helps you a lot when you try to retrieve data. From a database, when you want to retrieve data, if you know the relationships going forward, you will know the type of join query that you should put up. If this basic understanding is clear about your database, to do logical querying gets very, very easy. And that's the reason we are spending time on this. Once this bit is absolutely clear to you, and if any database is given to you, if you can understand the ER diagram and you understand what are the relationship between different entities and what are the type of cardinalities between these entities, it becomes far more easier to retrieve any kind of information, which in turn means that if there is any kind of report which is asked from you, you will be at lot ease to do the querying part because you understand your data completely. So a lot of time in organization, and this is with my experience, your MIS resource actually is struggling because they don't understand the database. They don't understand the relationship. They try to run a query which gives you incorrect results. Incorrect results because you don't know whether it is a one is to many relationship or one is to one. If that bit is not clear, the output will be incorrect. And a lot of times your MIS resources are not really very clear on these aspects. So this is one of the basic thing which you should know when you handle any kind of database or if you're planning to learn querying. If this bit is clear to you, which means logically you know which entity is where and which attribute, how it is related, then querying is just a simple task. It's almost similar to Atulya. If you remember, we had done few exercises in Excel. Unless you're clear of there also, if actually you make a diagram for yourself, it will become far more easy for you to put a function and pull out data. What we try to do is randomly use functions and then get incorrect results. So it's always a good idea to start with finding identities, putting the relationships, putting attributes, getting a diagram at least for your own sake, if not for the database management system. Ideally, this diagram is there in most databases. However, still some organizations don't really follow it strictly. It's more like the comments in coding. Some organizations don't follow it. But if you have a ER diagram in place, it not only helps you, like we discussed earlier, if there is a shift in the person or a change in person, it also helps in that. All right. Okay, so with that, we end the ER diagram piece. And now I will take you to a little bit of Excel that, SQL that we will see. Yes, so what we studied until now was data, databases, database management system, and RDBMS, right? Now the standard for all relational database management systems is SQL, which is nothing but structured query language. Query is more about retrieving data. So you query the data, that's what it is called. Okay? So this was again an IBM stuff, which was done in 70s, so pretty old and robust. This language is essentially used by a lot of databases even today. And once you know SQL, if you have to work on Oracle, SQL Server, MySQL, for that matter, any of these databases or Postgres, you can work very easily. Because there is only a little bit of syntax change. but the language is basically supported by all RDBMS. There are some slight variations which you can do with the interface that you use with. It is basically a non-procedural language. So the language will look something like this. For example, select customer.customer name from customer. We'll come to this, but this is just an example. Now, applications generally access a database through either an extension of embedded SQL, or they use an intermediary program, which is like an ODBC or JDBC. These are basically connectors. So Oracle database connector or Java database connector, which basically what it does is it picks up your query and it sends it to the database. Okay. This is a little bit about the history of SQL. So it started in 1970, like I said. There is also an important CORDS relational database concept, which is more about integrity and stuff like that. I would not want to get into the detail here. And this is how it has evolved. Currently, it is being used by all major database vendors that we know. Now, purpose of SQL standard. Why do we have SQL? Basically, to have a standard syntax for both data definition and data manipulation. It defines data structures and basic operations. What it also allows you to do is portability of data definition, which means you can move your database with the help of SQL from a Oracle RDBMS to a MS SQL, to a Microsoft platform. Or tomorrow, if you want to move it to open source of Postgres or MySQL, you can do that also. Okay. It allows for later growth enhancement to standard because it has referential integrity, transaction management, user-defined functions, extended join operations, and so on. Now, the SQL environment basically has a catalog. Catalog is nothing but it is a set of schemas that constitute the description of a database. Then it has a schema. Schema is nothing but it's like a structure which contains the description of objects. And you have the data definition language, which is called DDL in short form. These are basically commands which include things like create, alter, drop, and so on. We'll be going into details of this in the next session. Then you have data manipulation language and data control language. Control language is more about administering administrative privileges or committing data. That's what DCL is used for. Okay. With that, I think we will move to doing the installation of this. Yeah. So Atulya, you have your computer logged in? Can you share your screen? Are you in a position to share your screen? You're on mute.
Yes. I'm using my computer.
Okay, so if you can share your screen, we'll go ahead and together install your MySQL.
Okay.
The reason I'm doing it on your computer is I'm having a Mac. It will not help you. Which is your Windows version?
Windows 10 Pro.
Okay, fine. So you can go to MySQL.
We have to go to
MySQL.com.
okay.
Yes, press enter. You have a download section there.
Can you go to the full screen, please, Atulya?
Go to the second tab of downloads. Yes. Right next to mysql.com. Yes. No, 1 minute. Go down. Atulya, please wait for my instruction.
Downloads.
Go down the screen. Yes, so here you have MySQL community GPL downloads. That's what I want you to click. Yes, click there. MySQL installer for Windows. Yes. You'll have to check, is your system 32-bit or 64-bit? Or click the drop down, it will have Windows 10, I think. Yeah, no. Okay, can you just check your system is 32-bit or 64-bit? It will be in the system.
It says 64.
We're showing you both 32-bit. Yes. So just go back there. In Microsoft Windows drop down, there's nothing else, is it? It showed me a different screen. Okay, just go up to product version. Drop down there. Just pick the last one, 8.0.22. No, go back. Yeah.
What it should come as?
It should show 64-bit also. On my screen it showed.
Because on my screen also it is showing only 32-bit.
Only 32-bit? 1 second. Let me just see my screen, because this piece should be same, no? It's not.
Just show me your screen, please.
I'm just opening that. Just give me a minute. What was your address on this? 1 second. This is how I'm getting. And share that first. That's what you asked. राहुल आपका भी सिस्टम 64 बिट है और 32 दिखा रहा है क्योंकि ऑटोमेटिक पिक कर रहा है. फॉर मी इट इज शोइंग मी मैक ओएस 64.
Okay, 1 second.
Why is it not allowing me to show the screen? Can you do
Okay,
this, Atulya?
one second.
Go to Google and type MySQL for.
I got it now. I got it.
Hmm.
Even I got it. If you go to the bottom footer menu, from there, if you go to download, then it is showing 64 bit.
Okay.
There you go. From download section, it is not going, but if you go through footer, it is showing. You got it, Atulya?
Yes, yes. Correct. Which one to download? Zip archive, debug binaries, or
No, you can pick up the first one.
Fine. So just start my download.
You can skip this step. No thanks, just start my download. Down you have? Yeah. You can press open. No? Okay. Should not take too much time. Rahul sir, you are also downloading?
Now it is a zip file.
Yeah, so double click it. It will have an installer.
Installer. It's saying bin docs include library share license readme.
Where you downloaded it will be, no?
Yeah, it's a zip file.
Yes.
So if I unzip it, it is showing a lot of folders. 1 second, let me see what is in the folder.
उसमें installer है?
That's what I'm checking.
.msi फाइल होगी शायद.
Exactly. My SQL secure installation.
हाँ, do that.
कौन सा फोल्डर है?
bin में जाओ.
Bins.
No, it is enter password for user root.
Yes, so you will have to put a new password there.
Okay.
एक मिनट sir, we'll just get. हाँ, click on this.
Mm-hmm.
One minute. Yeah, go to bin. See if you have an installer file here. Rahul, you picked it up from bin only, right?
But the JavaScript is not working. Enter password for user root.
So you just enter one password.
Yeah, I entered it. Then it is. Yeah, let me see if it works now.
After that screen, it will ask you for. 1 second. I think what I can do is
1 second. I think it's happening.
No, Atulya ka is not happening.
1 second. Let me just see. होता रहा Atulya का भी. आप executable file पे हो. Which file are you clicking? No, don't do that. Come scroll down. Atulya, on the bins. Just scroll down further. You are on the bin folder?
Yes, yes.
Okay, just
Yes,
scroll
he's
down
in the
further.
bin folder.
I'll tell you the file name that I picked up.
No,
It says mysql_secure_ installation.
third file, Atulya, from top.
This one.
Yeah,
This
installation
one?
ex.
Ah.
Yeah.
Was this you were doing? Yeah, it's
No,
happening. Right?
he was doing something else.
Extracting, which is fine.
Yeah. So when you go in the installation, at one place it will ask you for products, where you also have to select MySQL Workbench.
ऐसा कुछ किया नहीं उसने मेरे साथ, लेकिन चेक करता हूँ.
एक minute.
Enter password for user root.
Oh, but this is not the graphical interface. This is what you got, Rahul sir.
Yeah.
Okay, put a
This
password here.
is not the one.
No, what I want.
Okay.
What I wanted was Windows का normally a graphical user interface होता है, उसी में it is asking for root. 1 minute, I had pulled it up from a free online resource which had the video. Just try and show that to you.
एक install rewriter है, ये तो नहीं चाहिए?
एक मिनट बता रही हूँ आपको. Just give me a minute. The file name was MySQL installer -community something.
MySQL community server.
Community server. Actually, एक minute. Can you just download the lower one, please? Click there. Say yeah. Let me see the file name, please. No, say open. Cancel this. Say open. that WinZip was fine. $64. Oh. 1 minute, Atulya. I'm just trying to share. It allows. Are you all able to see my screen? Atulya?
Yes, yes. Mhm.
So this is how you selected, right? This is how the installer looks in Windows normally. Can you see
Mhm.
a Windows
Uh,
installer? The
just share the particular link of the web page.
नहीं, ये तो खाली एक वीडियो है, वेब पेज नहीं है ना मेरे पास.
Mhm.
I'm showing you from a video which I fetched for a Windows user.
Just go back and just जहाँ पे explorer दिखता है वहाँ पे दिखा.
Yeah.
Mhm.
So actually installer community नहीं आया ना?
Mhm.
Because otherwise it will not allow you to do through a GUI selection of various products also.
Just start from the beginning.
Oh, this could be an older thing because it's 8.0.11. What we have currently is a higher version, 8.0.29 I think we have. So currently this drop down, it is not showing. Like for me, it is only showing a Mac. Oh, I think we are missing this 1 minute.
Go to download
1
page.
minute,
Yeah.
I understood.
Mhm.
We missed that one step, no? अतुल्य मिला आपको क्या चीज बोल रहे हो?
Mhm.
So whoever has done this has not picked any of this. There is a section which says for all Windows platform in one package. Or what you can do is just type download MySQL installer, no? For Windows 10 in Google. Can you share your screen now, Atulya? Installer for Windows 10. For Windows 10. Yes, enter. 64-bit VRAM. Good. You can pick up the first. No. Go to the down wala link. Correct. This will show you the MSI installer, I think.
Mhm.
Yes, now the down one.
Showing 32 bit.
32 bit. Pick that. No, that is not from MySQL. That is not from MySQL. That's a third party thing. Go back to that page only.
Way older version.
Why is it detecting your system as 32 bit? I don't understand that. राहुल सर आपका भी 64 बिट सिस्टम है और ये 32 बिट डिटेक्ट कर रहा है ओके नहीं आई थिंक विल रादर टेक द ओल्डर वर्जन अतुल्य because this is a third party now so this will be a different thing. It will not be the same thing. It will be difficult then. Shall we just try with the 32 bit only? Lower one, yeah. Click download. It could create issues later, but because ideally this site is auto detecting. For me, it is auto detecting Mac OS and 64 bit. I'm not sure why it's not detecting 64. Okay, check if the installer is done. Six minutes.
पारुल
Yeah.
इसमें एक है इंस्टॉलर वेब कम्युनिटी और एक इंस्टॉलर कम्युनिटी कौन सा रखना है इसमें
Installer community.
ओके और इसमें सेटअप में पूछ रहा है डेवलपर डिफॉल्ट सर्वर ओनली क्लाइंट ओनली फुल और कस्टम
एक मिनट
चूज द सेटअप टाइप
कस्टम आप चूज करिए
ओके
उसके बाद it must be giving you options of
Yes.
SQL server
yes
application so on, right?
Yes.
Click on
Yes.
SQL Server जो plus sign है.
Okay.
One more plus sign. It will show you MS
Yes.
MySQL Server 8.
Yes.
Click there
Yes.
on 8.0x64.
हाँ, यहाँ तो 64 बिट आ रहा है ना?
हाँ, तो वो 32 में ही आ रहा है. ठीक है.
हाँ, आ रहा है
Click
64
there.
बिट. Yeah.
फिर वो arrow green हो जाएगा तो just press the
Yeah.
it goes to be
I've transferred it to the product to be installed.
Then go to applications.
Enable the
next tab
select
down.
feature page, customize product feature और check करना है, uncheck
नहीं
रखना है.
नहीं अभी आपको और प्रोडक्ट सेलेक्ट करने हैं उसमें.
अच्छा, और क्या प्रोडक्ट सेलेक्ट करना है?
एप्लीकेशंस में
ओके.
एप्लीकेशंस में वर्क बेंच है. माई एसक्यूएल वर्क बेंच होगा.
या
उसमें भी इफ यू सिलेक्ट एक x64 वाला ऑप्शन होगा. उसको भी ऐसे ही ग्रीन एरो प्रेस करके यू विल गेट इट टू बी इंस्टॉल्ड.
डन.
देन यू क्लिक नेक्स्ट.
अच्छा, इस नीचे एक चेक बॉक्स आ रहा है, enable the select feature page, customize product features, तो उसको अनचेक ही रहने दो ना.
एक मिनट.
अनचेक ही है वो डिफॉल्ट.
हाँ, उसको अनचेक टू रहने दो.
ओके. एग्जीक्यूट.
नेक्स्ट.
या
हाँ, एग्जीक्यूट. Is it showing you something in check requirements?
No.
Then execute.
So it's done. Go to next. Ready to install.
आपका screen share कर सकते हो ना राहुल सर?
Yeah.
Atulya can also see and I will know what I'm talking. Otherwise I'm talking in the air. Yes, it is installing.
Give me a minute.
So sometimes before this step, Atulya, it can ask for other requirements, which if it says that Microsoft CC Plus is not there or something, just execute those options.
This file is 32-bit or 64-bit?
This is the 32 one only. Out when you go further, it is showing x64. So the installer that you downloaded, you can start your
Installation के
installation.
समय वो बता देगा 64 बिट.
हाँ. Once both are complete, you will click on next and it should product configuration, I think. Installation. Okay, finish. It didn't ask you to configure the.
Configure what?
It's done, is it?
Yeah, it says Windows closed automatically. 1 second.
Okay.
I'll just share my entire screen for a minute.
Because the version that I used, it asked me for the port number details. The standard port for this is.
This one?
This is, you have reached the MySQL workbench. Okay.
Shall I close it?
Yes, you can close it.
Okay.
Now, if you go to your start,
Okay.
there should be MySQL.
Yeah, सबसे ऊपर है MySQL workbench, MySQL command line, recently added.
Okay, you're done.
इसमें नीचे आके देख लेता है SQL में आने के ना इसमें.
नीचे भी MySQL में होगा.
Here MySQL.
Click on that.
Yeah, here 4 options.
Yeah.
Okay.
This is fine. This is fine. Atulya, you're done with this. You want to share your screen? We can help you.
It's still downloading. 1 second.
Oh, okay. How many minutes does it show?
Just few seconds.
Okay. So in the next session, what we'll be doing is we will create a database using a workbench. MySQL workbench is basically a visual interface which allows you to write to MySQL. So direct SQL is written like we saw earlier, where it was asking you on the terminal the root password. You can do that, but for that you need to know a lot more commands. So we'll be using the MySQL workbench. It started the installation, no? Yeah. And also, if you want to leave, you can leave, because we'll go forward in the next session. I wanted to complete the installation so that we are hands-on with that at least.
Okay, then see you.
Okay. Yeah. Bye-bye.
When is the next session?
I'll come back to you. I'll
Okay.
discuss with Atulya and come back.
Okay.
Yeah. We'll keep you posted.
Done.
Yeah. Yeah. Take custom. Next.
Next.
Go to MySQL servers. Click on that plus sign. One more click down. Click one more. Yeah, you can see X64. Yeah, click there. Press the green arrow. Yes. Go to applications. My workbench. One more click. One more. Yeah. So this is all 64-bit. Click on next.
Visual Studio, nothing else was.
No, nothing else. Yes, this is where I say just execute.
This will execute both.
Press execute. We'll execute one after the other, I think.
C++.
Because this needs C++. There must be some amount of coding of this in there. So if your system has this already installed, it doesn't ask for. You can close. Press close. Yeah. Next. Yeah. Execute. Next. Yeah, so this piece didn't come for Rahul. 1 minute. Yeah, so this is the default port, Atulya, 3306 that you see there.
Mm-hmm.
So each of these service has a port on which it runs.
Okay.
Okay. So the port, default port for MySQL is 3306. Okay. We will not change this right now. Configuration type 1 minute, just see the drop down. What is there? Development computer. First drop down.
Yeah.
हाँ, और क्या ऑप्शन है उसमें?
Server computer and dedicated computer.
So we'll keep it as development center. That uses minimum memory. Okay, click next. 1 minute. So all this should have come for Rahul. I don't know why it didn't come. These are the two types of authentication method. We'll use the recommended. Click next. Yes, now you will set the root password. This is the password to start or stop your MySQL server, which is your RDBMS server. You can put any password here, whichever you want, but don't forget.
This is like a phone password. No?
This is like a phone password. This will be required to start the server. For now, put it as 123, doesn't matter. Doesn't need to be too secure, but I don't know if it will allow or not. Okay. Now this is very down if you see. Yeah, that's okay. That's okay. Down if you see, 1 minute, don't click anything. You can add users. Click on add user. Right side you have add user. Yes, click there. So you can have different type of users with different rights. And for each user, you can create a username password. Okay, we are not doing this right now. These are the different types of users. Got it? So somebody who's only for administration of a backup, you can give him just those rights. So you can have a backup admin, you can have an instance manager, so on. Cancel this. But this is how users are set in a database. Okay. Next.
The password.
Okay, now 1 minute. So here two things. It says that you can start MySQL server with your system startup, which is what we'll keep. Okay, run the service. Okay, this is fine. Click next. So these are the changes it is making. Execute. Whatever password, etc. you set, it will go ahead and do this. I think for Rahul, he had installed the SQL separately and set the root password. So this didn't ask. I don't know. Something happened.
जो previously जो command prompt आया था शायद वहीं पे
उन्होंने वहां
पहले
पर
हो चुका
पासवर्ड कर दिया तो but now I don't know how to we will have to link that instance with the SQL bench workbench. I don't know if it happens automatically or not. Okay, finish. Next. Okay, finish. This will now open your my workbench, MySQL workbench. Yes. All right. So this down, if you see, there is an instance already running on localhost 3306. That is the port number. Here, if you give the password now, yes, same password which you put there. Press OK.
Save password in board.
It will save it in its own memory. Yeah.
Connected.
And this is where we'll be writing the scripts. All right.
Okay.
Good, Atulya. So we have reached a place from where we will now learn. We will have to get a test database, and then we'll start learning about how to create a database here from a schema. I think we'll start with a schema database, then do querying on database, and then we'll understand different types of databases. All right.
Sure.
Chalo, with that we can end today's session. Okay, are you able to understand any issues with speed, content?
Not a problem. अभी तक तो वैसा कुछ नहीं. Like,
ठीक है.
we'll go further शायद तब doubts वगैरह जब
हाँ,
आएंगे.
ठीक. नहीं, आज के सेशन में कुछ भी आपका इनपुट या फीडबैक है तो टेल मी so that I can incorporate that in.
हाँ, it's good. Fine. Good problem.
Okay, fine. So we'll end the session for today. Good night.
Okay. Good night.